This is my work on work, energy and power. I titled this one work, and I'm going to give the definition of work using a formula. In this formula, you are going to understand when work is done and when work is not done. Remember, please, to subscribe to my channel and press the notification bell so that when I have a new video, you will get alerted and you can then watch my new video. Now, you can call us on 070 50 68 18 54. So let us get started. If this body move from here, if this body move from here to here, we say that it has covered a certain distance or a certain displacement S. Let this one be force F. Let this one be force F. Work is defined such that we find the component of F that is horizontal. The component of F that is horizontal. When you find the component of F that is horizontal, it will give you F cos theta. It will give you F cos theta. And by the definition of work, work is equal to F cos theta multiplied by S. So this will give me Fs cos theta. So by definition, work is a scalar quantity. By this definition is showing a scalar quantity. So work is a scalar quantity. So what is going to happen? We have different conditions in which work can exist. For instance, if we have the condition 1, if my theta is 0, I then have work to be equal to Fs cos 0. This will give me Fs. What is cos 0? 1 times 1, and that will give me Fs. When theta is 0, then the force is along this direction. The displacement is also along this direction. It means both the force and the displacement are along the same direction. As a result of that, our work is simply force times distance, or force times displacement in the same direction. We look at condition 2. Condition 2. If my theta is 90 degrees, then the force is along this direction. The force is along this direction. So we have this. The force is along this direction. So theta will be 90 degrees. So let theta equals 90 degrees. Then with our definition of work, Fs cos theta, this will give me Fs cos 90 degrees. And what is cos 90 degrees? 0. So I have Fs multiplied by 0, which is equal to 0. This tells us that when the force and the displacement are perpendicular, when the force and the displacement are perpendicular, no work is done. No work is done. No work is done. Now, let's look at this. Your JAMB exam, you have a bowl of water on your head and you are moving straight forward. You are applying a force on the bowl of water, but the displacement is along a straight line forward. In physics, you have not done any work. You have not done any work because the force you applied on the bowl of water is vertically upward, while the displacement is along a straight line along forward. So in that case, there is no work, and work is equal to 0. Let's look at condition 3. Condition 3 or third condition. Third condition. Third condition. Third condition. In this third condition, we are going to talk about when theta is along this direction, that is when theta is equal to 180 degree. When theta is equal to 180 degree. So let us draw a horizontal line, and my force is like this. This is equilibrium position, or the main position rather. So if the body is moving this direction and the force is along this direction, displacement along this direction, but the force along this direction, they are directly opposite, displacement and the force. In terms of vector, this is what is called anti-parallel vector. Anti-parallel vector. So if this is positive, then this is negative. As a result of that, we look at our formula. Work is equal to Fs cos theta. Fs cos theta. Fs cos theta. And that will give me Fs cos 180 degree. This is Fs multiplied by -1, and that will give me minus Fs. This is negative work. In physics, you are only working, but there is nothing for you to show for what you are working for. So we call it a negative work. You can see this one in a question that is related to friction. There is a question in Lamlad textbook which I'm going to solve in my video, in my second video. I'm going to show you how this one is very useful. Now, if you look at the first condition, we show that theta is 0. Second condition, theta is 90 degree. And the third condition, we said theta is 180 degree. Let's look at the fourth condition. Let's look at the fourth condition. Fourth condition now. Fourth condition. Fourth condition. In this fourth condition, we make our s to be 0. We make our s to be 0. So using the formula, W is equal to Fs cos theta, and we have F times 0 cos theta. So since we have 0 here, everything multiplied there will give me what? 0. That means when you are applying force, look at this. If this is an example, I'm applying a force here, but the body is not moving. Because the body is not moving, I am not doing any work. So in physics, work is equal to 0. Thank you for watching my video.